Hi guys, we're looking at depreciation or decay. So under depreciation or decay we have simple interest decay and we also have compound interest decay. Okay, we are starting with simple interest decay first. Okay, so simple interest decay, which is also referred to as straight line basis decay. Okay, so if you see on a question they say calculate this that depreciating at on straight line basis, then you know that is a simple interest decay. Okay, so this is when the value or the principal amount decreases. Okay, this is when the value or the principal amount decreases. Okay, it works like simple interest, but the value decreases rather than increase as with simple interest. The formula has a negative operator. Okay, so what they're saying here is simple interest decay or straight line basis decay is when the value gets reduced. Okay, so let's say for example if you own a car and they say the value of a car depreciates, it means you buy a car, let's say you bought the car for 300,000 and it depreciates. It means it loses value, so by the time you sell it you won't be able to sell it for 300,000 rands. You'll be selling it for a lower price because it has depreciated. Okay, that is what it means. So simple interest decay means it depreciates similarly to how simple interest investment grows. When we say remember with simple interest we in investment we said you add the percentage agreed upon based on the principal amount. So similarly here with the simple interest decay, it gets reduced just like that based on the principal amount. Okay, so that is what it is saying. So what happens here is they are saying the formula has a negative operator. So when they say the formula has a negative operator, this means the formula of simple interest, that same formula we used for simple interest investment, we're using it, but instead of using a positive here, we're going to use a negative implying that it gets reduced. Okay, it gets reduced. Okay, I hope that makes sense. Okay, so you see this is going to be your interest, this is the number of terms. Okay, so it gets reduced like that. Okay, so here's the formula here. So let us look at this first example here. A car is valued at 240,000 rands. So a car is valued at 240,000 rands. If it depreciates at 15% per annum using a straight line decay, you see, straight line decay. So once they say straight line decay, we know it is what? Simple interest decay, because it's just interchanging the words, right? The two terms, they are talking about the same thing. Okay, so they're saying if it depreciates at 15% per annum using straight line decay, calculate the value of the car after 5 years. Calculate the value of the car after 5 years. So now here's the car. It is valued at 240,000 rands, right? So after 5 years you cannot sell it for 240,000 rands. Why? Because it has depreciated. The value of that car has been reduced over the years, so you have to sell it at a lower price. So how do we calculate that new value for that car? How do we calculate the new value for that car after 5 years? That is what we're looking into. Okay, so what do you have? You have the principal amount, which is the current value for that car, which is 240,000 rands, and we have the interest rate given per annum, 15% per annum. I divided by 100 here to convert it from rate to our interest here, so that we can be able to substitute it on the formula there. Okay, but you can also just take it as 15, substitute and divide from there within the formula. Okay, and n is the number of terms. In this case it's years, so it's going to be 5 years. Okay, so we substitute in the formula. A is equals to P into 1 minus, not 1 plus, because this is decay. When you say decay, something is getting reduced, the value is getting reduced. So 1 minus in, okay, so 240,000 into 1 minus 15% divided by 100 multiplied by n, which is 5. Okay, so this gives us 60,000 rands. Okay, so this tells us that after 5 years the new value of that car is going to be 60,000 years. So meaning now if you buy a car now for 240,000 rands, in 5 years when you sell it, you will sell it for 60,000 rands based on 15% per annum depreciation rate. Okay, so that is example 1 there for simple interest decay. Okay, let us look at another example. Let us look at another example and try to do more of it, because you know, the more you do this examples, the better you become at it and you start to understand it more and more, you know. So let us go to another example and look at another example. Okay, let us look at another example. Okay, let's go to the next page. Okay, so activity 1. After 4 years, the value of a printer was half of its original value. Okay, so here's a printer, right? It has a certain value. Let's say the value is X, and after 4 years the value of the printer has been reduced. It is now what? Half of what it was initially. So meaning if the value of the printer now is X, after 4 years the value of the printer is going to be what? Half of X is what? Is half X. So the current value now is what? X. The future value after 4 years is what? Is half X. That is what they are saying. So you need to be able to interpret what the statement is trying to address. Okay, so after 4 years the value of a printer was half of its original value. Determine the rate at which the value of the printer depreciated over this period. If the depreciation was calculated according to straight line method, okay, again, straight line method. So what do we know when they say straight line method? It's a simple interest decay, okay, meaning we're going to use this formula. Simple interest decay is this formula, similar to the formula for simple interest investment. The only difference is that it's a minus here instead of a plus. Okay, remember that. So now they are saying we must calculate what? They need us to calculate M, right? They need us to calculate R, the rate, right? They need us to calculate the rate, interest rate. Okay, if the depreciation was based on a straight line method, okay, over that period, right? So, and the period is what? 4 years. You see that, right? So what do we have? What do we know? We have A, because they said after 4 years the value of the printer was half of its original value. So it means if the current value is P, the future value after 4 years is what? Is 0.5p, is half of P. Okay, so that is why we have A there. And I, we do not know I, but we know I is R divided by 100, right? I is interest rate divided by 100. That's how we normally substitute. We say R here divided by 100. That represents I. Okay, and N is the number of terms. In this case, because this is yearly, N is what? The number of years. Okay, so we substitute here. A is 0.5p because it's half of P after 4 years, equals to P is the current value, and into 1 minus I times 4. Okay, I multiply by 4 because 4 is N. I we do not know. Okay, so when you calculate, divide both sides by P cancels P, you get 0.5, 0.5, 1 minus 4i. Okay, so you take 4i to the left side, you bring 0.5 to the right side, you have 4i equals to 0.5. Therefore your I becomes 0.125. Okay, I becomes 0.125. And to get R, we know I is equals to R divided by 100. So if you need R, you have to multiply I with 100. Okay, so R is equals to I multiplied by 100, which is 0.125 multiplied by 100, and R, the rate, is what? 12.5%. Okay, the interest rate is 12.5%. So this means that if the printer had a value of X, and it was depreciating at 12.5% using straight line method, after 4 years, if its original value was P, after 4 years the value is 0.5p, is half of what it was. Okay, so that is based on this 12.5%, right? So this is what it tells you. So in other words, let's put this practical with a number. If the printer was 20,000 after 4 years, if the printer depreciated using straight line method at 12.5%, if the initial value of the printer was 20,000, so it means after 4 years the value is going to be what? Half of 20,000 is going to be what? 10,000. So that is what the question was about. So just try to read the question properly, don't rush it, make sure you understand what the question is asking. Okay, so if you can understand what the question is asking, it becomes easier to answer the question correctly. And again, they are saying straight line method, so you need to know that straight line method is associated with what? Simple interest decay. Sometimes they'll say straight line method, sometimes they'll say simple interest decay. So you just need to know any of those two wordings or terms refers to that formula that we were using there. Okay, so let us look at compound interest decay now. The second one is compound interest decay. Remember, we came from investments, we spoke about compound interest investment. In that case, the money was increasing, right? So in this case, because it's a decay, the value is decreasing. Okay, so what other term do they use if they don't want to say compound interest decay? What other term can they use? Sometimes they will use this term, reducing balance basis. So if you read a question and you see they're saying calculate blah blah blah, depreciating using a reducing balance method or reducing balance basis or all that, so you know that this speaks to compound interest decay, and the formula becomes that one for compound interest. But remember, it's decay, it's depreciation, so minus. Okay, so depreciation here or decay. Okay, then you know that it's going to be minus there. All right, so what is compound interest decay? Okay, this is when the value or the principal amount decreases, right? Is when the principal amount decreases for a certain item or product. Okay, so it works like compound interest, but the value decreases rather than it increases as with compound interest. So in this case, the value decreases. You know, it's not like back then when we were doing compound interest investment where the value was increasing. Okay, so that is just what they're trying to say. So the formula has a negative operator. Again, the formula has a negative there because we are used to the formula having a positive sign here for investments, compound interest investments. So now this is compound interest decay, compound interest depreciation. It's being reduced, you know, it's being reduced, so it has to be minus. So if you read the question again, they say compound interest decay or they say reducing balance method, you know the formula has to be this one. Okay, the formula has to be this one. Okay, so let us look at an example here. Let us look at this example. Hudiso buys a farming truck. Hudiso buys a farming truck for 182,000 rands. So he buys a truck, and the value of the truck at that time he buys it is what? 182,000 rands. Okay, the truck depreciates by 17% per year, right? The truck depreciates by 17% per annum. Remember, year means what? Annum, right? So the truck depreciates by 17% per annum. So don't get confused by the wording. So know that sometimes they can use this, sometimes they can use that. So be familiar with all these wordings or these terms. Okay, following a compound depreciation method. You see, following a compound depreciation method. Again, we are back there. Compound interest. You know, decay, reducing balance, compound depreciation. So once they say compound, we know the formula has to look like this with n as the power, right? Once they say depreciation, we know the formula has to have a minus there. So again, know the terms so that you know how to apply and which formulas to use. Okay, so let's read the question again. Hudiso buys a farming truck for 182,000 rands. The truck depreciates by 17% per year following a compound depreciation method. Okay, what is the depreciated value of the truck after 11 years? What is the depreciated value of the truck after 11 years? So we need to know after 11 years how much can I now sell this truck for. Okay, so what do I have? Okay, I do not have the future value because that is what we are looking for. We want to know how much is going to be after 11 years. Do we have the current value? Yes, we have the current value. Currently the truck is valued at 182,000 rands. And do we have the interest? Yes, we do have the interest, the rate of depreciation, depreciation. Okay, so it's 17% per annum. So I'm dividing it by 100 again for the conversion. And how many terms? Well, this is yearly, so it's 11 years. Okay, so we use the formula, we use the correct formula for compound depreciation. Compound to the power n, depreciation minus here. Okay, so use the formula. A is equals to P, which is 182,000 into 1 minus R divided by 100 is what? 17 divided by 100. Okay, so that is 17 divided by 100. Okay, there's been a mistake here of dividing by 1,000 instead of 100, so I'll correct that. So all to the power n is what? It's 11. Okay, so A, the new value is what? 23,438,53 rands. Okay, so that is the new value of the truck after it has depreciated over 11 years. So that is how you go about depreciation or decay. Okay, that is how you go about depreciation or decay. Yeah, so you need to know, you need to be able to understand what the question expects from you. Okay, let me try to quickly dissect this again. So you buy a farming truck, right, at a current value of 182,000 rands. So it gets it depreciates, meaning the value of the truck gets reduced based on a compound method, right? Compound we know to the power n, but because they are saying it is depreciating, we know the formula has to have a minus, right? So you need to know what is going to be the new value after 11 years, considering the reduction of value based on that depreciating rate. So that is what the question is about. So read the question correctly again to make sure you understand it properly. All right, okay, let us look at another example here while we are still on compound interest decay, or rather the reducing balance method. Okay, 6 years ago Dolly bought a phone for 13,000 rands. Okay, 6 years ago she bought a phone 6 years ago for 13,000 rands. Okay, the value of the phone depreciated annually. So the value of that phone depreciated annually according to the reducing balance method. Again, here's that word, reducing balance method. What do we know about reducing balance? It's a compound interest decay, reducing balance. When they say reducing balance, it's the same as they are saying compound interest decay. So I spoke about this, said they can interchange the terms. Okay, so the value of the phone depreciated annually, yearly, according to the reducing balance method, according to the compound interest decay method. Okay, now they say here the value of the phone is now 8,337.75 francs. So this is the new value of the phone after 6 years, because remember 6 years ago when she bought it, it was 13,000 rands, but now 6 years later the phone is what? 8,337.75 rands. Okay, so now there's something they did not give us here. What did they not give us? Well, they just told us that the phone depreciated annually according to reducing balance. They did not say anything about the rate of depreciation. Do you see anything about interest here? Nothing, right? So let's look at the question. Calculate the annual rate of depreciation. There we go. Now they want that part that was missing. Calculate the annual rate of depreciation. So now we want the rate, that annual rate of depreciation. Why annual rate? Because it depreciated annually. That's what they told us. That's what they want here. Okay, so what do we have? We have we have the current value is 8,000 here, 8,337.75, and the principal value, the value that the phone had 11 years sorry 6 years ago. Okay, 6 years ago. So P, when she bought it, it was 13,000. That is P. That is the time she was buying it. That was the present value at that time, right? But after 6 years, that is the new value of that item after 6 years. Okay, so that is the new value is going to be 8,337.75, and we do not know, because we want the rate of depreciation, we want R. So we know I is what? Is R divided by 100. When you substitute I, you say R, whatever the number they give you in percentage, divide by 100. So that is what we know. And n is number of terms. In this case they said annually, so n is going to be 6 years. So we substitute on the formula of compound interest decay, because they said what? Reducing balance method. Okay, so A is 8,337.75, P is what? 13,000 rands, and into 1 minus I. But what is I? I is what? Is R divided by 100. So that's why it's written like this, and close bracket to the power of n is 6. Okay, so I want to stress that on this part of I, you could also just substitute I and calculate I. Then in the end, when you have I, you just multiply by 100 to get R. I did that, I think, on a previous question for simple interest decay. I took that approach. They wanted R, where I think I got 12.5% at the end, but I used I, and I went down with I. After getting I multiplied by 100. In this case, I'm substituting R divided by 100 from the start. So it's two ways of doing it, so you could use any of the two. It's correct. Okay, it's mathematically correct. So now you go with the calculations, you simplify, and R here, R over 100 is equals to 0.0714, and you multiply by 100. Therefore R is equals to 7.14%. Okay, so here they said calculate the annual rate of depreciation. So the rate of depreciation is what? 7.14%. Okay, so that is it. Okay, so this is a depreciation or decay topic. So please go through these examples again, make sure you understand them, and try to solve question papers where they speak about depreciation to test your knowledge and your understanding. Okay, the next topic I'm gonna go into is gonna be addressing the nominal interest and the effective interest. When they give you now an interest on an item, and they say it is compounded to a certain period, now they say calculate the effective interest of that item. That question also comes a lot on question papers, so it's going to be the next topic under finance. I'm going to do it, and after that I'm going to be looking into annuities, your present value annuity and your future value annuity. Okay, so good luck, keep practicing, and be on the lookout for the next recording